Hello everyone. This video is going to focus on the angles of parallel lines, and one of the things I want to point out about parallel lines is that these are in fact lines that do not intersect, and they are coplanar, but we'll just focus on the fact that they do not intersect. This also includes segments that are contained within lines. Now you'll notice from this diagram you should see that two lines look parallel, but we can't discern that for sure until you actually spot something like this, and that is an arrow that is mid-line. If you can spot that, then you have confirmation that the two lines are parallel. You might even see two arrows instead of one. In either case, if they have the same number of arrows, they are parallel to one another. I want to underscore that parallel does not necessarily mean congruent. Here's an example. Here you have two segments. Both are parallel because they're equidistant at every single point, and yet you can plainly see one is definitely longer than the other. With every set of parallel lines, you will always get another line that crosses through. This line is called the transversal. It is the transversal that creates all these different angles that you see here, and it is all those angles that we will focus on for this video. Let's number these angles. Since there are 8, we have them numbered 1 through 8. You'll notice that there is a region between these parallel lines. Any angle in between are referred to as interior angles. Whereas if it's not on the inside, we refer to them as exterior angles. So angles 1 and 2 are exterior angles. 7 and 8 are also exterior angles. The transversal also separates into two parts. You have a part to the right and a part to the left. If you have angles that are one side and then the other, they're referred to as alternate angles. So in conjunction with the other ideas, we have alternate angles that are interior and alternate angles that are exterior. Or if you have angles that are just on one side, they're referred to as same side angles. Take, for example, alternate interior angles. Alternate interior angles are two angles that are in the interior. So we're talking perhaps angles 4 and 6 or 3 and 5, so any of these. And also on alternate sides of this transversal, which meaning that we have one to the left and we have one to the right. So if we consider, say, angle 4, then an alternate interior angle would not be 3, because 3 and 4 together gives us this linear pair of angles. So we mean angles that are not already linear angles or vertical angles. So that leaves us with one alternative. If you have angle 4 and we want an angle that's on the alternate side, the right-hand side in this case, then we mean angle 5. So angle 4 and angle 5 are alternate interior angles. Notice also that alternate interior angles form the letter Z. So you'll find a Z shape whenever you find alternate interior angles. The two angles created by the Z are the alternate angles. You should be able to see another pair here. Therefore, angles 3 and 6 would also be alternate interior angles. Keeping with that theme, what about alternate exterior angles? Alternate exterior angles kind of follow the same logic. We have angles in the exterior, so we're talking one of these 4 paired up with another one of these 4, and on alternate sides of the transversal, so one's to the right and one's to the left. So if you have, say, for example, angle 1, then an angle that would match with it would not be 2, because again, if it's 2, then what we have is a straight line and a linear pair of angles. The problem with this is that it has nothing to do with the fact that we got parallel lines. You just have one line here and then a line crisscrossing. That does not take into account this other parallel line. So you need to incorporate an angle from one parallel line and from the other parallel line. So let's go back. We have angle 1. It won't be angle 2. That leaves us with angle 8. And if you're wondering why it's not 7, it's because, again, you have an angle on one side, and then on the alternate side of the transversal. Corresponding angles is a combination. We don't talk about alternate when it comes to corresponding angles, so we mean on the same side, either both on the right or both on the left. We also don't talk about interior or exterior, and since that's all there is, what we really mean is you have one in the exterior and you have one in the interior. So we mean a combination for both of these. So consider, we could practically pick any angle and then try and match them up. Find one in the interior, find one in the exterior. Say, for example, we chose angle 3. Now, since we mean an angle on the same side, and it's got to be exterior, again, keep in mind what's wrong with angle 1 here. We have a straight line, linear angles, so that doesn't work. So we mean one that's farther away. That leaves us with 7. So angle 3 and angle 7 would be examples of corresponding angles. Just as you might say that angle 1 and angle 5 are corresponding angles. One's inside, one's outside. What about on the other side? 2 and 6 would work. Do you see another pair? To kind of finish up on this, these three sets of angles are congruent to one another if the lines are parallel. If you don't have one of these three established, and by the way we're excluding vertical angles, then the two angles that form a pair would be supplementary. The one pair of angles that are supplementary that come up oh so often are same-side interior angles. Just as the name suggests, we're talking about two angles that are in the interior, and they're on the same side. So in this case, both on the left of the transversal, or both on the right of the transversal, but not one from each side, because that would be alternate. Same-side interior angles are also called consecutive interior angles. That's a name that is seen in some textbooks. Others will have same side. They both mean the same thing in that they are right next to each other. In fact, you'll find that same-side interior, or consecutive, form the letter C. So a lot of times you'll want to look for the C shape. In the interior here you see that C shape. It is of course a bit backwards, but nonetheless you see the two angles that are trapped by that C shape, angle 4 and angle 6. So those would be same-side interior. You should see another pair going the other way. So angle 3 and 5 also work for us here. This last one that we'll discuss, same-side exterior, is less common. Same-side exterior are talking about two angles that are still on the same side of a transversal, both on the right in this case, or both on the left, but just in the exterior. So we're talking essentially, say, angles 1 and 7, or angles 2 and 8. Those two pairs would be supplementary. So angle 1 plus angle 7 totals 180, or angle 2 plus angle 8 totals 180. And again, keep in mind we wouldn't say 7 and 8 are same side exterior because, well, first of all, they're on alternate sides, and also because they don't make use of the parallel lines. You know, one's here and that's it. We don't even need this one here if you're talking about 7 and 8. This would be an example of a linear pair of angles. Okay, that ends this first part. Now move on to part 2.